Okay, today's video is going to be about GraphQL, Vertx, and React. This time I'm going to be building the app with Kotlin instead of Java. So before I do that, I want to show you what we're going to build. So this is the application on the left-hand side. As you can see, it's a task list application. It's going to show all the tasks on here on the right. And then if you want to add a new one, you can add a new one. All of the queries, this and all of this stuff, and the mutation right here is all GraphQL. So we're going to learn how to do that. On the right over here is a plugin from Apollo that lets you basically test your queries and mutations. So for example, I can do that. So before I start, just for people not familiar with GraphQL, basically all it is a standard for defining a data schema in an API. So basically, even though I am using, for example, Apollo, this plugin for GraphQL on the client side, my backend is Vertx GraphQL-Java. So a completely different vendor, and yet, they communicate and it works. And it's because there's a standard query language typing schema that is used throughout, even if they're different vendors. So I will be showing you how to create a schema file, which will define all the types that your API is sending back. So that's kind of part one of GraphQL. And then the second part is something called resolvers. And basically, they're the things that get you the data that populate the schema types. Now, resolvers, all it really means is they're your CRUD operations. So whatever ORM or whatever backend you have, as long as the types on the schema and the entity models that you have line up, everything will work. And then, of course, there's some glue code that has to be created to merge the two together. So this is the app we're going to build. Once again, we're going to go to start.vertx.io, and like I said, this is going to be a Kotlin project using Gradle. Obviously, you can do whatever you want there. The thing you want to make sure is that you have Vertex Web selected for the dependencies, the Web GraphQL handler, and then also the reactive libraries, version 2, and Kotlin coroutines. So I've already downloaded this, and it created a default project. So let's get started by modifying this project to be GraphQL enabled. Okay, so we're going to create a new vertical. So this vertical is going to contain our routes. It's going to contain the execution of our HTTP server, and it's going to contain our GraphQL service. Now, in order to get the GraphQL service up and running, we have to create an actual GraphQL schema file. And that schema file has to end in GraphQLs. So inside of this GraphQL file, we're going to be defining all of our entities. So what this means is that we have an entity called user, or we will have an entity called user, has a field named ID of type long. Long does not exist by default in a GraphQL schema, so I'm just going to define it right there. This means that there's also a field name, and it's of type string. This just indicates whether it's nullable or not. Exclamation means that it is not nullable. So then we'll have a task. The task will also have an ID. It will also have title, description. Description is going to be nullable. So these are our entity types. So what happens now is, on top of defining our Vertx HTTP server and the routes, we also have to grab this file. So I'm going to grab the file. GraphQLs. Just please remember, you have to put this file into the resources path in order to be found. So our handler, if it finds the file, it's going to set up our HTTP service, our routes, and the GraphQL service. Now, in order to do this, or have this entire system work, we have to use cores in this case, because the React client is on a development server, and that server is running basically a development server on port. Currently it's port 4000 for me. It may be a different port for you guys. So we have to create a cores service handler, route handler, I mean. And it's going to decide what client, what URLs can access this server. Because we are using JSON from our client, I am adding that specific header. So this is going to be our cores handler route. The cores handler package is already part of the HTTP web service package. So like I said, my client is on port 4000. So I'm adding my headers. So that's my first route. And then next, we're going to add the route that does the GraphQL stuff. So that has to be on post. So we have the basic pieces for our HTTP server and our routes. And then now we have to create our GraphQL service that is going to be handling our GraphQL API route. So in order to do that, like I said before, we need to merge our types with the actual queries on the back end that are going to be receiving the data. And then those queries have to be aligned to the schema for the entities that you see here. So in order to do that, first thing we're going to do is we're just going to grab the strings inside of our file, our schema file. So that's that. And then I'm going to create the entities, put it into their own package. So some of this boilerplate code I already have, so I'm just going to copy and paste it. But basically what I'm doing is, because we don't have time to create a database and all of that stuff, I'm just doing an in-memory data store for now. So we don't need that. So let's make it static. In fact, I'm just going to copy and paste these over. Actually, let me create the entity models first. So I'm just going to create a data class. It's going to have an ID, non-nullable. It's going to have a name, non-nullable. Whoops. So we'll create our task. Which will also have an ID. It will have a title. It will have a description. So now that we have our entities, we can go in here. That's our user entity. So I have this preset collection of data. So this is the existing list of tasks. So the next, what I want to do is, I'll do this slowly. So the first thing that I want to do is I want to get the get user query working. So we're going to have our backend call, our quote unquote backend call to get this data. So obviously this is going to our in-memory data store. It's getting the first user that it finds by the given ID. So now we come down to here. But what has to happen here is this schema has to now be glued with these backend entities and calls. So first thing I have to do is I have to finish the schema. At least the one we're going to do for now. So we have our entity types with our scalar long, but also we have the first query that we're going to be getting. So then now we have to write code that glues these two guys together. The schema type and the backend. So that I'm going to create a new package. So this file is going to do the actual merging. GraphQL-Java calls it wiring, which I really hate that name, but that's what they use. So this file is going to contain our data fetchers. And what data fetchers means is it's roughly synonymous with resolvers, although not quite. So basically, the data fetcher is the thing that's actually getting the data for the purposes of merging with the schema, but that data is coming from the CRUD operations, which we defined over here. So it's creating a definition basically that is showing the relationship between the query type, the appropriate query type, and the task. Excuse me, the entity query. So in this case, in order to get that, we need to pass a parameter. So in this case, that's the ID. So you do it like this, or you grab it like this. The environment is sort of like the routing context. It has a lot of the information that's coming in during a request. So then I'm going to take our static method getUser, and hopefully this is going to be successful later, and it'll give us our data. So this is basically a wrapper around the actual data query itself, which allows passing of any parameters that might be being given to it, and then also taking the result and passing it to the GraphQL system. So now that we have that defined, we have to do our first set of wiring. So this piece is quite involved. I'm going to be honest with you. I'm not really a fan of GraphQL Java, but you know, this is what needs to be done in the Java world, which Kotlin is a part of. So there is actually a K GraphQL library, but it doesn't seem to be that popular. So I was a little bit hesitant about using it. So that's why I ended up just, you know, picking this. So let me just explain this. So the merging or the marriage of the type schema with the backend entity calls is happening in this code that we're about to write, and which they call wiring. Okay, and what you're doing is you're taking the schema. In this case, we're defining the query. If we were defining a mutation, we would do this instead. But we're defining the query. And then inside of the query, we're going to define all of the actual query calls. So later we'll have get task as well, and that'll show up below here. But for now, we just have get user. So again, this thing hooks up to the data fetcher. And then now we've wired to the actual backend call. After this, I have another function which does the work of merging the two. And creating the actual schema object itself. So we need a schema parser, sort of like a JSON parser. It understands the type language. It looks for any issues, that sort of thing. So we have that, and that becomes our type registry. So wiring, registry, data fetcher, these are all specific to GraphQL Java. These are not really terms that I've heard of as part of being GraphQL proper, at least not in the Node React world, which is where I started with the GraphQL stuff. Okay, so now we've stitched everything together, and then we have to pass everything to we have to create a GraphQL object and pass this stitch schema to it so that it can do the work. So we're going to grab our schema, from the function we just finished creating, and then we're gonna return a new GraphQL service object. So this guy that's being returned does the actual work of taking the queries given, passing them off to whatever the resolvers are, retrieving that data back, converting it to the type system of GraphQL, and then sending it off to the client. So now that we've defined everything, we can come back to this file. We'll define our GraphQL object here. So that's our schema string. And then we're going to get the, we're going to set the route. It's going to be a post. We'll call it GraphQL. You can call it whatever you want. We're creating a new handler, and that handler is going to be the object that we just finished creating. Oh, I already had this here. Okay. So let's just review real quick. We set up a router. We set up the first route, which is to do CORS handling. Then we set up our marriage of schema and resolvers for GraphQL, created the service, and then created a GraphQL specific route. So now all we have to do is create our HTTP server. We'll put it on 99.99. Just want to make sure I'm not missing anything here. I think that's good. So let's see if this builds. Okay, so that was successful. Now, I was showing you this before. Don't think it's going to come up now. I think the client has to have the Apollo GraphQL stuff in there already. Yep. Okay. So we're going to add all of our client-side GraphQL stuff. So that's going to be npm I. It's going to be GraphQL, the package. It's going to be GraphQL-tag. This is going to allow us to write the schema language on the client side and get font formatting and colorization and all of that stuff. So then this is basically helper methods for the Apollo GraphQL client. And this is the hooks library. So this is what you need. Now, I've already installed these. So I'm not going to install them again. So what we need to do now is we need to import. So the first thing we're going to import is the Apollo provider. I forget what has the Apollo provider. Apollo hooks. Okay. And then Apollo client is going to be in Boost. We also need a couple of things from inside of it. This is to allow us to do caching. Actually, that's the only thing we need. So in here, we're defining the URL for our Apollo server, which is 99.99, and then GraphQL. And then for caching, we're going to use that in-memory cache that I just imported before. Spelled that wrong. Okay. So I'm pretty sure that's all we need to get the Apollo plugin working. But let me check that. Let's close out of this. There it is. So this is a tester. It has code completion, and it allows you to check that your queries are working. Oh, gotta pass parameters. So let's just take person 1. So as you can see, the back end at least is up and running and working. So now we got to finish our front end. So we're going to go here. Let's separate out our GraphQL queries just to keep things clean. So like I mentioned before, GQL is going to allow us to write the type syntax and get formatting and colorization. So here we're going to do it's going to be the same syntax that we saw before, except what's going on here is there is a sort of wrapper label that acts as a bridge between our React code and takes parameters from our React code, accepts them in, and then passes them into the real query mutation subscription. So that's why there's that dollar symbol there. So then once we get the data back, let's just take everything. So just to be clear, if I wanted to, I could omit ID and not get back ID, or omit name and not get back name. But in this case, I just want to get everything. And then I want to export this out so I can use it here. So this is a lot of boilerplate code, I guess you could say. So this time let's do ID number 2. So I'm going to explain this code right now. So obviously this is our get user. This is use query, a hook from Apollo React hooks. So this allows us to actually get the data back, assuming there's actual data to get, because I did make it nullable. So once the data comes back, I'm going to put a greeting message in here. So in order to do that, I'm going to do it with this. So I want to make sure that this data is coming back. If it doesn't, I'll just exit. Now the data is stored with the same name of your actual GraphQL query. So obviously that's get user in this case. So I'm going to create my greeting. My greeting is going to be whatever the person's name is. IntelliSense is not being my friend today. Okay, so we had a rebuild, no errors, and we got Tim back. If I were to switch to, then we would get Pam. So obviously that works. So now we're going to add get task so that we can list out our tasks. Since I'm assuming you guys are familiar with Kotlin, and this is pretty simple code, I'm just going to copy and paste this. So that's going to get our task data. So we have to create another fetcher, data fetcher. The reason why I'm using a mutable list, if you're wondering, is because later I'm going to be updating the list, the in-memory list. So I just want to make it easy for myself to do that. So this one is pretty simple because we don't have any parameters. So that's really all there is to it. So like I was mentioning before, whoops, we're not there yet. Sorry. We are not there yet. So this is just a query. It's not a mutation. So we just need to define it in the same place inside of query. So now I have all of the resolver side stuff done. So I got to come back in here. So the brackets is the array syntax. Oops. When you don't have parameters, you don't need to put in the parentheses. So this is the array syntax, and you put it inside. And then again, this is to indicate I don't want any nulls inside of it. But the array itself could be null. So I don't need to update this because this is already part of it. So that should be it. And then if I come back in here, let me refresh this. You can see my task. And you can see my small data set. Okay, so the backend is working. Okay, so I want to make the front end code a little bit, how should I say, a little bit nicer. So what I'm going to do is create separate components for different things. So the first thing that I want to do is I want to create a task component. I'll put it into shared. And this is basically going to be one of these. So to do that, obviously we need React. I'm going to create a task CSS file. And I'm not going to explain much about what's in this CSS file. Since the main point of this video is not styling, but be aware that it is making pretty heavy use of the grid, the CSS grid. So anyway, we create a task. This is coming in from the SCSS file. Yep. Let me show you the... Oh, it's not going to show up. Task, title, description. So this is just going to be a render component. So it's not going to have any state of its own. It's just going to get it passed in. But since this is TypeScript, I'm going to define this so that we have some type safety. So now that I have this, everything is, there's no errors. So the next thing that I want to do is I want to create a task generator. So basically what this does is it takes in the data from the GraphQL server of these task items, and then it builds out instances of task as required. So let me just copy and paste these imports. So again, I'm making this the default export. So I am going to, actually there isn't even anything in here. Let me just delete that. So I'll create another interface for the props. So I'm expecting an array of this thing called task model. So I'm putting my entity models in here. This is pretty simple, so I'm just going to copy and paste this. It's a class with the same fields and some default values. So that was found, and I'm using it as the type. So I have that. So now I have this local state. And it's going to be of React elements. And I'm using the onload basically to give me the props, and then in here I'm going to convert them into React elements, and then I'm going to populate them here or display them here. So again, this guy is converting the data into these React elements. So assuming task list, the data, has some values, I'm going to loop through them. And I'm going to create individual task components. And then I'm going to add them to the total array. So whenever you create these multiple elements inside of another element, you always have to make sure that you have a unique key, or else you'll get errors. Okay. So then once I'm done populating these, I have to refresh the state. Let me show you, whoops, more of the file. So I get my data come in, and I'm going to let this live inside of app. So app is going to get the data, pass it in. I have local state, which is a bunch of React elements. Those React elements are task components. So when the data comes in, I'm going to make sure it's not null. Then I'm going to loop through all of them. Whatever I find, I'm going to create a new task element out of. Then I'm going to populate the local state, and I'm going to draw it out here. So then in here, right here, because again, I'm using grids for everything. So this is the right-hand column. This is the left-hand column. So in here, I'm going to have that component that I just created. But the other thing that I need to do is I need to create a new query for get tasks. So this one doesn't have any parameters. But I just want to check something. Actually, it's using full length. Whoops. All right. So now I have the schema updated. So now I need to put in the actual records. So I'm going to create another state object. It's going to house the data that comes back from get tasks. So I create another state object. It's an array of task model, or it's null. So this thing is going to require another use effect. Let's just stick with the naming convention. All right, so I save that. Then in here, whoops. I want to pass my local task list. So no errors. So again, starting from the top, getting my tasks as defined here, picking out all 3 available fields. Again, if I wanted to omit, I could, but in this case I won't. Then I have local state. I probably don't need to do this. I probably could just pass in this data straight away, but it's usually a good idea if in here you're doing some kind of data validation just to make sure. But anyway, for demo purposes, I think this is fine. So I set this local data, and then on the right hand side column, I'm using the generator to create all of my actual instances of this component. So this auto refreshed because of the because this was watching my code. But as you can see, because these two are coming off of the same data. Oh, wait a minute. Okay, the fields were blank because I actually had everything still as ID. So obviously that doesn't work. Now, this doesn't work either because desk is not the name of this field. So I'm going to update that as well. Let's put in some data in here. Yep, so it works. So once again, we created the query based on the schema syntax. We created a mapping model, only not necessarily because we need it, but for type safety purposes. Created a distinct component for each individual task element. We created a task generator, which takes in the data from the GraphQL query and builds out an array of tasks. Then we use the app to run a query, the get task query. And then once it ran it, it populated its local get task based on the task model. Obviously the fields line up, so they just auto map in. And then we put that onto the right-hand side column, which is right here. All right, so that is the get tasks. And the next thing we're going to do is the mutation, which is going to be submitted by this component right here. So as before, let's create the backend first. So again, we're going to update the schema file. After creating a mutation schema, we have to put one in here. So now that I have the schema, I want to create an actual CRUD operation. So let's just increment. So then now we have a new task object. Then we're going to add it directly to our list. And then we're going to return it. So that's our CRUD operation right there. Then we need to update our fetcher. Now again, as I said before, I really don't like this library, but I'm having to use it because the alternative, the GraphQL for Kotlin, doesn't seem to be as well used. So I'm a little bit wary of it. So that's why I didn't do it. But the reason why I don't like it is these very strange naming conventions that they use. It just annoys me, coming from Node and Apollo GraphQL. So let's see here. Let me just move this out of the way. So what's going on here is, you never want to block the event loop on Vertx. So I'm making sure that I return a completable future object. Now, I've been in the forums, and one of the people told me that under the covers, GraphQL-Java actually does some sort of conversion anyway. But regardless, I'm just going to do this explicitly. So like I was saying before, we can use the environment to grab any parameters that are coming into us. So in this case, we need the title, and it cannot be empty. Okay. So now we're going to add the actual task itself. I'm going to return the promise right here. So again, I get the two arguments. I make my call. I get back the data. I return the data. I believe this has something to do with Kotlin and Java interop, but I'm not sure. So anyway, now we go back in here to do the wiring. As I said in the beginning, you need a separate type wiring for the mutation. And then if you had a subscription, this would be the case as well. So we only have one data fetcher. All right, so we did that. Everything else is the same. Let's make sure this compiles. And it does. We're just testing here, so let's just, yep. So we only had 3. Now we added the 4th. I didn't get back the title and description because I didn't want it. So you see that it updated. All right, so that's the backend changes. Now let's do the front end. So we're going to be putting our control, again it's this guy, into the left-hand side column right here. We'll create it as a separate control. So it's going to be new task new task creator. Again, I'm not going to show the CSS. If you guys want to look at it, it'll be in my GitHub. But this is basically it. Again, heavy use of grids. So I'm just going to copy and paste the imports once again. So once again, we have to create the new query. In this case, it is a mutation. So like I said before, this is a wrapper around the real call of the same name. It's basically a handler that takes the React stuff, React parameters, and then passes them into the GraphQL call. So we're gonna get back everything. All right. I am just going to copy and paste the JSX because I'm sure you guys are pretty familiar with writing JSX. But basically, it's a form. I have it separated into two columns, the left-hand side and the right-hand side. As you saw before, the left-hand side is all the labels. The right hand is all the inputs, and then the button to submit. Okay, the first thing we want to do is set up the title. It'll be blank for now. Then we want to set up the description. That will also be blank in the beginning. Then we set up the task, the GraphQL query executor. So in this case, we're using a mutation. That's why this is. Okay. All right. So those of you that are not familiar with Apollo GraphQL on the React side, this is basically making sure that once my add happens, any data that should update and reflect that change happens. So, and the reason why that's necessary is because internally, actually I do need that. Internally, GraphQL is caching this data on the client side. So we need to make sure that a refresh happens on the client to avoid stale data. All right, so on change title. This is going to have to be async. Because we're going to await this call. And inside of it, we're going to pass our variables. In this case, it's title and description. Okay, we can get rid of that. So then again, we'll go in here. Okay, so this time it compiled successfully. As you can see, the input box is here. The last one we added is task ID 4 test. So I'm going to do test new task A, new description A. Okay, I know what's going on. So the so the query is asking for a description without the correct field name, DESC, but it's supposed to be the full word. So test A. There it is. So our queries, our mutations, we did not have to create any kind of custom browser query or tester UI. It's built in as a plugin to Chrome on a Vertx backend. That's it. Thanks.